All right, you're good to go. So good afternoon, good morning once again. Thank you for attending this webinar. I really appreciate you sparing your time to attend this. This is about performance tuning series, and this is designed for prospective DBAs as well as experienced DBAs. Prospective DBAs are in the sense of those who have either taking the training or taking some courses. They're trying to transition into the DBA world, but let's say they haven't started working yet. This will be beneficial to them, and of course people who are already working as well. This will help to enhance what you do at work when it comes to performance tuning. So the tag for this series is PTS 2026, which is performance tuning series. And it's a series. And of course, as we are aware, TV series have seasons and episodes. So the plan is that it will be continuous, at least for some time. Okay. All right. So a little bit about myself. My name is Adewale Adeniji. I'm from Oyo State in Nigeria. Of course, I'm a senior database administrator, and I have these certifications: the Associate Azure and the Expert Solutions Architect. I'm also a certified trainer by Microsoft. And this shield down here shows everything that I would have become if I wasn't a DBA. So pretty much my hobbies. So that soccer represents or shows that I love to play soccer. So maybe I would have become a professional soccer player. Um, the airplane there shows that I love to travel. That paper or the graduation is I think it's an iPad. Okay. Shows that I love to teach. That shirt shows that I love fashion. I like to dress well, look good, and smell good. And in red, you have my initials. So that's just a little bit about myself. If you can also put in your name and let's say your location and where you what you do for fun, put them in the chat so we can get to know each other. In the chat, please. You don't have to unmute. I think I muted everyone except people who just joined recently. All right, thank you. So about this series, like I said, it's a series, so there are multiple episodes, maybe multiple seasons. So we have, for this one, we have 4 episodes. The first episode is about troubleshooting and monitoring of, database performance. The second episode is going to be on index tuning. The third episode will be on query tuning. And then the last one will be on server tuning. But the one we are going to focus on today is obviously troubleshooting and monitoring of performance. This is more like the first thing you need to do when you want to troubleshoot or when you want to fix the performance problem. For those who are already working, I'm sure you would agree with me that your database performance will not stay the same over time. It deteriorates as you begin to add data, into the database, as you begin to, as users begin to connect and manipulate the data, like insert data, delete, update, and even read. All these things affect the performance of the data and even the hardware as well. So we're going to be looking into how to do root cause analysis and find out what problems or bottlenecks or impediments our databases are facing. So that's what this session is going to be about today. And then the next episode will be about how we can tune the indexes used by queries or processes running on our servers. We all know that index is meant to help to hasten how data is being retrieved. But oftentimes we find that we have those indexes, but they are not helpful, which means they are not useful. Sometimes we have too many indexes. Sometimes we don't have enough. So we're going to look into how we can optimize the indexes on our servers. And then the third episode will be on how we can tune queries, especially. So we start off by identifying those resource consuming queries, those queries that are posing a lot of bottleneck impediment on the resources on the server. So we are going to look at how we can identify them today, which is part of the troubleshooting and monitoring. And then the third episode, we'll talk about how we can optimize those queries so that they can run faster and then, of course, use less hardware resources. And then the last episode will focus on server tuning, how we can optimize the configuration of the servers to improve the performance of the server. And there's a lot of settings that we can tweak following best practices to enhance how our servers would perform. So the dates for episode 2 through 4 has not been determined yet. So I don't want to commit myself. It has not been determined yet, but I promise you it's not going to be far away from today, so that you won't forget everything that we learned today. And of course, this session is being recorded, so we have the opportunity to watch it, rewatch, as many times as we want. All right, like I said, today we're going to be focusing on troubleshooting and monitoring. And we're going to be using the first responder kit for troubleshooting, as well as third-party monitoring tools. I'm just going to show, there's a lot of third-party monitoring tools in the market. So I'll just demo with just 2 of them. And I'm not going to disclose their names for now. I'll demo with 2 of them. And the reason why I'm doing this is because some companies do not allow the use of first responder kit. Because first responder kit is open source. It's a kit that has multiple open source stored procedures that are built on DMVs to get some information about the servers, performance metrics and all of that to help us to troubleshoot and, find the root cause of the performance bottlenecks on our servers. But some companies do not like open source, for the fear of SQL injection and all that. So they don't allow the use of this. And I'm sure that if they don't allow the use of this, they will either have inbuilt or in-house stored procedures or DMVs that they use to troubleshoot and monitor, or they leverage third-party monitoring tools because they are enterprise software and they're kind of like more reliable compared to open source. A little bit about first responder kit. It's the stored procedures in this kit are for the most part developed by Brent Ozer and some other developers because it's open source. So if you're really good at developing, you can definitely contribute to the FRK. There's a bunch of stored procedures here, but we are not going to cover everything for the sake of time. But we will cover the main ones that we need and the ones that I use for the most part whenever I'm doing performance troubleshooting. So I'm pretty much sharing my experience on how I've been able to use these to tune performance. All right, let's proceed. And then if you have any questions after this session, these are the contacts you can reach out to, or you can reach out to me through the website of our Wade services. We have a YouTube channel. Please kindly subscribe to watch some videos there. This is the Instagram handle right here at Await Services. It's my business phone number and then business email address. Thank you. So now let's dive deep into the demo. Enough of the PowerPoint. So I'm using SSMS 22 as my GUI to communicate with the database engine. I'm also using some other tools that I want to share with you in case you need to like practice or demo on your own. But the main focus of this is for you to apply the concept you're going to learn from here in your work environment. But I also strongly encourage you to, practice in your personal lab. So, the first on the list is that I'm going to be using SQL Stress Tool. This is a software developed by Eric, and it is used to stress load your server. Because on your personal laptop, your server does not have, too many processes or queries running. And if you want to demo or simulate a production environment, you need to apply some stress or workload on that. So this is very useful in order to do that. And I'm going to be using this as well. It's pretty straightforward. If you go to this website address, you can download it, and then there's a documentation on how to use it. That is outside of the scope of this session, so I'm not going to be talking about that. Of course, we're going to be using the first responder kit, and you can download that from this website. This script will be provided to you after this session. I want you guys to focus on this, and then you can practice while you rewatch this recording. So also on this website, you can find the documentation on how to use the first responder kit, the different stored procedures, the parameters they use, and all of that. We're going to talk about them, but this documentation will provide an elaborate in the context. Of course, I'm going to talk about SPO is active by Adam Mechanic. You can download that from this GitHub account. And then the documentation of which is active can be found here to learn more about the parameters and how you can tweak it to suit your need. For demo purpose, I'm using the Stack Overflow database, and you can download that from here. There are different sizes of the Stack Overflow database. I'm using the 2013 one, which is roughly about 50 gig in size. If your server will not accommodate that, there's a smaller one. I think the 2010, that's about 10 gig. It's still going to give you pretty much the same results. So it's because I have that bandwidth in terms of storage. That's why I prefer to use this. And then to stress load your server, you can download a query to do that here. And this query is what you will use or integrate into the SQL Stress tool to put pressure on your server. And then I disclose this one. So yeah, this is the monitoring tool that we're going to be using. There's another one, forgot to put that one here. So SolarWinds DPA. DPA stands for Database Performance Analyzer. It's a third-party tool, enterprise software. You can download it from here to get the trial version. I think they give you about 14 days to test it out. But for you to be able to download this, you would need a business email address. They're not going to give it to you if you put Yahoo or Gmail because it's enterprise. So they want to make sure that you're going to be able to purchase. You're likely to purchase after testing it out. And and it's not for personal use, for business use. I think I covered pretty much everything. Okay, so the first start procedure in the first responder kit that we'll be talking about today is called SP_Blitz. So I'm going to relate some of the things that go on in the internals of SQL Server to human beings or real life situations, just so we can relate and understand. You know, as humans, we are encouraged to go for, medical checkup, like annuals, like once a year or maybe twice, just to see what's going on in our body and all that. It is expected that as DBAs, we do the same for our servers to check the overall health of your servers, see what's going on inside of it. And the benefit of this is that it will help you to detect or it will help you to standardize your server. So what SP Blitz does is to run some DMVs, capture some metrics, and then present the result to you to tell you the things that you are doing wrong that you're supposed to be doing right, obviously. And then it gives you a recommendation of how to right those wrongs, So it tells you the current state of your server as against the best practices. Um, so this start procedure has a lot of parameters that you can supply to it to give you results. In order to see those parameters, you can run this query with SP_help. This is generic for any start procedure. It will give you the parameters that any start procedure uses. Another way to find the parameter of any start procedure is to check on the GUI and Object Explorer. So if I pin my Object Explorer here and I go to Stack Overflow, oh, no, sorry, it's not Stack Overflow. My start procedure are in the DBA database. So if I come to DBA, expand these, go to programmability, I come to start procedures, expand, I'll see the start procedures there. I hope my screen is very clear so I don't need to zoom in. I try to increase the font as much as possible. So these are the start procedures. So for Blitz, if you click on this plus sign and then you see parameters, then you see all the parameters. And this applies to any start procedure. You see the parameters that start procedure uses. See, there's a lot of them. Don't be bamboozled. Trust me, I don't even use all of that. I don't use majority of them. And that's why I provided the link to the documentation that should you find yourself in a situation where you need to use them, you can just read the documentation. But for the most part, I've probably used just a few of them. But it's good to know that these parameters are available in case you need them. So if you don't want to go this route, you can run this query to see those parameters. I'm going to do that right now. And the reason why I'm having these here is because I installed or created those stored procedures in the DBA database. In some companies, they put them in the master database. Now I'm assuming that you know how to do that, how to create these stored procedures. All you got to do is just go to this link right here, download it, copy the scripts, paste, select your database context, and then run. So I don't want to, go through that here. I'm assuming that we all know how to do that. So I'm going to run this now. And this will tell us all the parameters here in this start procedure. See, there's a bunch of them, but I'll show you the ones that I use often. I feel like my screen is too condensed. All right, so now let me show you how I use this store procedure and the parameter that I often use. So if I run the store procedure by itself without supplying any parameters, I'm going to do that right now. So what the store procedure does, like I mentioned earlier, is to run some DMVs to gather some metrics and tell me what I'm doing on this server that is wrong and what I'm supposed to be doing. So it checks the health of the server. Just like when you go to a hospital and then they take your blood sample, urine sample, and then, they'll tell you for every metric, they'll tell you the value of your blood sample for that metric. And then they tell you like is it the recommended or the standard one? Then you will know if you are below or above, that range. So that's exactly what Speed Blitz does. I hope I'm not stress loading my server. It shouldn't take this long to pop out results. Okay. And I believe I increased the RAM. Okay, alrighty. So now we have the results. So the result comes out in a prioritized format. Yeah, prioritized formats. And according to Brent, you want to focus on priorities 1 through 49. Those are the ones that are very critical. Those are the ones that if you don't correct them, you can get fired for. Okay, and you can see the priority, the first column here says priority. If I scroll down, you see that it increases downwards. And then here, so from line 16, which is priority 50 downwards, there are things that you're supposed to do, but are not very critical, on your server. They're not critical. But if you do them, then even better. But the ones that you have to do are the ones from priority 1 through 49. And you will agree with me. So the first one here, priority 1, talks about backup. Now, every database administrator will agree with me that you need to back up your, excuse me, you need to back up your databases, should disaster happens, right? I intentionally did not create any backup job yet so that I can demo this to you. So, and it tells you what database or databases have not been backed up. See, that our backups not performed recently, and this is the database, and all of that. So on this column here, it provides you the URL that tells you the importance of taking the backup of your database. Okay, and then if I scroll to the right, it also tells me that, it gives me details of the last time the backup was done, and here in this case, it's never been done. And then query plan. I don't usually use these last 3 columns. Okay. All right, so let's go to another priority or another finding group. Still priority 1, but now we're talking about reliability. And now we're talking about DBCC check DB, which is what we do to check for inconsistencies or corruption in the database. And this is also very critical to be done, but obviously I've not been doing it on this server, and that's why it's pointing it out to me. And if you go to this URL, it will tell you the importance of that. And this has never been done, just like the backup. So this stop procedure SP Bleed, it's best to run. Let's say you just got into a new company, they just hired you, and you want to understand the environment. That's a very good time to run SP Bleed, just to understand the current health status of the server. Or let's say you just spun up a new server for a new application, you want to run this as well to make sure that you cross all the T's and dot all the I's. You have all the backup jobs and everything in place. Or maybe you just got a ticket assigned to you that they've been experiencing some slowness on a particular server that you should please look into it. It's also a good time to run a split to see, the health status of that server. And this other one is that user database is on C drive. This is another priority one. Okay, this is priority 20, actually. And this is also important or critical because if you put your user bases on the C drive, we know that the C drive holds the operating system. So if it crashes, the user database is gone. The same for your system in case you do that. So one of the best practices when you are installing SQL is to not install on the C drive or do not put your user databases on the C drive so it doesn't crash with the OS. So this here gives you the details of what you're doing wrong. So, and then when we get to 50 here, it says the recovery. This is more like a server tuning stuff. The recovery interval is not optimal. You want to set it to an optimal value, which is here. Let me expand this. You know what? Let me collapse this URL. Then let me expand this guy. Yep. So here it says the database has a target recovery of 0, which is a legacy default, and should be changed to 60. So this is part of server tuning. You want to change this to 60 to help you recover or retrieve your database. Another one here is that this instance has not been patched. See, it's being used, but it's not been patched to the current CU, which is CU3. This is a 2017 version, and says we recommend patching to take advantage of the increased analytics when running, blah, blah, blah. Apart from that, when you patch your server, it helps to improve the functionality and the security. So this is good when you want to standardize your environment. So someone is asking, is it advisable to follow all recommendations always from priority 1 to 9? Also, are there some instances when these recommendations hurt performance instead? I haven't experienced any time that these recommendations affect performance. However, as a DBA, when you run this and you get all this stuff, you just don't go ahead and start implementing this standardization. You have to carry your manager along. You have to carry, because they could have a reason for not doing what you're doing. So you want to carry them along, and of course, you want to get approval before you do anything. But these things are expected to improve the performance of your server, not degrade the performance. What if the client do not want you to change the interval? Then that's why I think I answered that. So it's not entirely up to you. Your responsibility is to point out those bottlenecks or bad practices, and then you recommend that this is what needs to be done. But if they agree or give you approval to do it, you do it. If they say no, then you have to lean back. But it will be on record that you mentioned that in case something happens in the future. You say, oh yeah, I told you so. All right, so okay, so these ones are not really important, system, database on C drive. I mean, they will not affect the performance of your server. Yeah, but it's just bad practice because you can lose data in case the C drive crashes. But it doesn't mean your server will be slow because it's on the C drive. No. Make sense? And this dedicated admin connection is disabled. This is necessary in case, your server is on fire, nobody can connect. It's encouraged to have your DAC enabled so that you can connect. At least only one person will be able to connect in that time to find what is going on. Let me see. So here he's telling us that we have some jobs, agent jobs without, email notification in case they fail. Of course, we know that this is also good. In case the job fails, you want to receive notification so you can, go ahead and troubleshoot why it failed and fix it. Okay, I don't have a fail-safe operator, blah, 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 blah. Query store is disabled. It's not critical, but it is encouraged if it is approved to enable query stores so that it captures metrics of queries that are running in a particular database so that you can use them for troubleshooting purpose. Okay, so that's just that about SP Blitz. It just helps you point out those bad practices on your server that could affect the health of your server and what you need to do to fix them. So these are some parameters that I use with Blitz. I'm just going to use the first two to show you guys. So if you include this parameter at check server info, what it does is to add some additional information about the server in the result set for you. So right now, because I ran it without a parameter, if I go to the bottom of this result set, there's no information about the server. There's no server information. But let's say it's a new server, you're a new DBA, or you're a new DBA, you want to understand the server, you want to include this to have a feel of the config, the hardware and the databases and stuff like that on that server. So I'm running this right now to include those information in the result. Another one that I'm going to talk about is the output type, because sometimes when you do all these things, you don't want to keep the results yourself. You want to communicate with the leadership, and they're not really interested in these great results, right? They want like a summary of what is going on that server. So this output type is good because it presents the result to you in a markdown format that you can send via email to your boss or the leadership. And then the other parameters are self-explanatory. So because, like I mentioned earlier, findings that are, that have priority 50 and above are not really critical. So you may not want to focus on that. So you want to, if you don't want to have those in your result set, you want to use this parameter right here to ignore priorities above 50. Or you can put any other value there. Doesn't have to be 50. So that's when you would use this. And then if you have on your instance, if you have more than 50 databases, this might take a while to run. And if you don't want to waste time, you want to include this parameter here. Okay, so now we have this. This is going to give us the same result set as before, plus the information about the server, which is going to be at the bottom. So yeah, so from here, let me just go up a little bit more. Yeah, from here, we have information about the server, last server info. It's telling us how many databases we have on this instance, the total size of those databases, the space on the drives, as you can see. That way you can quickly know if your drive is running out of space or not. What else does it tell you? It tells you the memory on that server. It tells you the NUMA configuration. It tells you the operating system. It tells you the last time it was restarted. And this was started like 2 or 3 days ago. It gives you the name of the server. It tells you the service account, the service and the service account running those services. Just some information. And it lets you know if your server is a physical server or a virtual machine, just some information that's just FYI. Okay. All right. So now let's check the output type and see how the output will be different from this grid that we see here. So I'm gonna include these. I don't know why my server is slow. It's always slow whenever I'm presenting. I'm going to take this out and put this parameter there. So now, let's say I want to, send these findings to my manager. I will run this because you don't want to. I mean, of course, you can copy these and post in an Excel, but it's too much information and it's not even well articulated. So I will run this instead. All right. Who is going to enable the DAC? The DBA. DBA is part of the configuration that you have to do. The DBA enables the DAC if you are given approval to do so. Okay, so this is the last thing. Okay, not the last thing. Okay, while that is running, let me talk about this. So as there will be times where you want to track the result of SP Blitz over time. So you want to save the results in a particular table. So because you want to, let's say you just got hired and then you want to know the current health status of the database of the server right now. So when you run the results, when you run this, you can save the results in a particular table using these parameters here. So this output database name tells it what database you want to save it to, what schema you want to save it to, and what table you want the result to go to. You can give any name for these. It depends on your environment. And then it will save the result there. So you can use this as a baseline or a benchmark. After you have standardized the environment, you can run it again and then compare and contrast to see the changes that you've made or the improvement that you've had on the server. Okay, and this is how I pretty much use SP Bleeds. All right, so our markdown is here, and then when you click on this, it opens up in a new window, and then see. This is easier for non-IT or the leadership to read compared to the grid result that we saw earlier. And you can edit these accordingly before sending it out to them. Okay. All right. I'm gonna close this. Any questions about Blitz? Please send in your question in the chat before we move to the next start procedure. The table gets created. Yes. So even if the table does not already exist, it creates it for you. Good question. So should I actually run this? Let's see. Okay. So let me show you that this table does not currently exist, and I'll run it, and you see that it will be created. So this is DBA. See, right now, I only have one table in the DBA database, which is SQL Server versions, right? So if I run this now, even though this table does not currently exist, it will be created for me. So if I run this, just that it might take a while. But while that is running, let me pull up the second start procedure that we're going to be talking about. Okay, bleed is still running. So up here, pretty much the same thing as we saw in the previous window, just information about this series and myself and the tools that we are using here, where you can get them from, and blah, 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 blah. So the main discussion starts from here. So unlike SP Blitz, that, helps us to check the health of our server. SP Bleed First helps to check real-time or instantaneous performance or health of your server, like what is going on right now. But Bleed is just what's going on, ever since you spawn up the server. But this one checks what is going on right now. What is the current problem that this server is experiencing right now? So it's more like an emergency, like you want to call 911. So this is not annual check that you go for. So SP Bleach is like going for the annual check. This is when you actually get sick and you need to go to the urgent care or the emergency room for help. So that's when we run SP Bleach, when there's fire on the mountain. So now this is done. Let's go back here. So let's go check the Update Explorer. So if I refresh tables, and then bam, this is it. So the result has been saved in this table for us. Okay. All right. So back to Blade first. So you want to run this when your server is on fire. Let's say you get pulled into a breach called, oh, this server is currently slow. Can you please check? So that's when you want to run SP Bleeds first. SP Bleeds is just when there's no concern currently at the moment. It's just, the server has been slow recently. Can you please check? Just normal annual check. So let's see what parameters SP Bleeds first uses. So if I run this, or if I check the Object Explorer, you see those parameters. There's a lot of them, as expected, but trust me, you would not always use all of them. Okay. Yes, there's a lot of them, but you don't always use all of them. But I'm going to share with you the one that I use the most. All right. So, but let's say there's fire on the mountain. I would like to just run, this. No, sorry. This without any parameter is not, you don't want to run when there's fire on the mountain. You want to include some parameter when there's fire on the mountain. But let's say you just want to run this to see how it works. Okay. So let me run this first without any parameters. So the way this stop procedure is designed is that it's expected by default to run for 5 seconds if your server is not, there's no fire on your server, and it helps you to find the current problem on that server in terms of the wait type or wait stat that your server is going through, and it's going to list those wait types for you in the order of severity. Yes. So, but because I don't have any queries running right now on this server, if you see that if you check this also, the result comes prioritized, just like Blitz. See, I don't have any priority 1 to 49 yet, which means there's literally nothing critical because obviously there's nothing or no query running as of right now on this server. The only problem here is that it says there's a query problem and that statistics updated recently. And if you look at the wait stats, this is the top wait stat on this server during the 5 seconds that this start procedure ran. So what it does is when it starts to run, you run some DMVs, capture some metrics, wait for 5 seconds, run the same DMVs, capture some metrics, and then compare. And it gives you its findings. Also give you some server information such as batch requests per second. This can be gotten from the performance monitor. And this is just a measure of how much work your server is doing, how many queries it is processing per second. So if you look at the value here, it says 27.00. This is a board server. This server is board. It's not doing anything, obviously, because it's not a production server. And if you want to learn more about each of these findings, please feel free to explore this URL here. Okay. And it also tells me the current CPU utilization within that 5 seconds that it ran. And you can see that it's 14%. The wait time per core, like how much time you're waiting for, resources per core per second, 0 point something. That's not a lot because there's nothing running. It gives you the number of databases you have on the server, which is 6, the size of the databases, the memory grant, and all of that, and the thread time, how much time queries are spending on the CPU thread. So because there's nothing going on right now, see, we couldn't find anything. So now I'm going to stress load, excuse me. So some of the parameters that it uses has like they have like default values. One of them is at seconds equals 5. Like I mentioned, it only runs for 5 seconds to capture a snapshot of the metrics and then present the difference, the delta. So even if you don't include this with this value, it still runs with this value. But you can alter this value to like 10, 60, 30, just to get a more representative sample of what is going on in your server. Because I feel like 5 seconds is, kind of small. But it's good if your server is on fire because you want to see what's going on in a very short time. And this will take longer than 5 if there's fire on the mountain. So I'm going to pull up my SQL Stress tool. Okay. Bear with me. My server is hanging. So this is the SQL Stress tool that I said we used to stress load our server. I already have my connection and everything set before now, so I don't have to go through that to save time. So I'm going to click on File to load my setting or settings. I have it right here. So here I'm executing this stored procedure. Inside of this stored procedure, it will be executing a lot of other stored procedures using some random numbers. And then I already created a connection to my database. If you want to see that, you can just click on database here. And then this is my connection. See, this is my server IP, blah, 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 the login, and then the database that I'm using. Okay. So, and I've saved that it should go 2 iterations and run on 2 threads. This server that I'm using has, I think it has 4 cores and I think 16 gig memory. I think we saw that earlier, but we can check here. Big properties. Okay, yep, 32 gig of memory and 4 processors. Okay, so where's my stress tool? This might take a while, so I don't want it to. Okay, I'll stop it when it's. But let me just stress load it. I'll click go, and that would execute this query. And then now that we have something running, and let's say we get called as DBA, like, oh, come and check something slowing down the server. Then when I run this, I should be able to find some problems because there's something actually running right now. So I'm going to run this again. And this is expected to run longer than 5 seconds because, users are connected and running queries simultaneously by virtue of that stress loading that I'm doing. So I'm just trying to simulate what happens in the production environment where applications, users are connected, and then there's slowness, and then you are being asked to come and troubleshoot. Okay, while that is running, we can talk about the other parameters. Okay, so you can change the value for these at seconds as you deem fit. So it's the duration of how long you would take the snapshot of those metrics for. And another important parameter that I use is if I don't want to go for a particular second, if I just want to see the overall bottleneck affecting the server performance since the server was restarted, you want to use this guy right here. Since startup equals 1. So we'll go as far back as when the server was restarted and take a snapshot and take a snapshot right now and then compare. So it's like the entire uptime of that server, not just what is happening right now. And then if you want to get some more detailed information, you can use the expert mode. It is encouraged to use expert mode as DBAs because it gives you more information about what is going on the server compared to if you don't use it at all. And then if you just want to get the top weight type, nothing else, you want to use the output type equals top 10, and it will display the top 10 weight type for you. So when you have processes or queries running and you run these, it displays different result sets for you. The top result sets are the active queries while this is running, like the queries that are currently running while this is running. So in order to get the result, I'm going to stop the stress load so that this can finish. I'll just hit cancel. So now I'm no longer loading my SQL server. And then you can see, you just drop the result. So now let's see what's going on. So we are not going to see that different, what is it called now? Different result set now because I killed it and I didn't even put the expert mode. But if you take a look now, you can see that we have more problems that have been identified because it ran longer. And then we have more weights compared to the other time where it showed us only 6 packets. And these weights here, they're in order of severity. So the first one is the top one, then followed by this one, followed by this one. We're going to talk about some of these weights, and then when we get to index tuning and query tuning, I will demo how you can fix some of these weights. But today, I'm just going to briefly mention or describe what they mean. But there's also a URL here for you if you want to read more on this weight type. Of course, you can use other resources as well, Copilot, ChatGPT, and other likes. Okay, so I'm going to include. So if I include in startup, you will see you might see a different weight type because it's now capturing from this time it will start up, not just right now. But to save time, I'm just going to include the expert mode so that you see that it will give you more information compared to what we have right now. And of course, I'm not currently stress loading, so this should go fast. And we are using the default at seconds equals 5. Should we use, let's just increase it a little bit. Seconds equals, let's say 10, just to deviate from the default. And then run it. In the environment, feel free to play around with the numbers. There's no what do they call it now? There's no one size fits all. Feel free to play around to just capture metrics. So the first result set here, like I mentioned earlier, is meant to be the active queries. The queries that are currently running, but because I stopped the stress load, you don't see anything because there's no query running. And then the second result set here is what we saw earlier, pretty much. the current problems and the top weight and some information, blah, 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 blah. So if I scroll down, and then you see those weight types in order of severity. Okay. Here, so let me just explain the result set to you. This is where it gets interesting, actually. So this column is just telling us the date that this stock procedure was run, which is today. The second column is how long it took to take the sample. Remember that we put at 10, but it took the sample for just 8 seconds. And then within these 8 seconds of taking the sample, queries were running for 12.4 seconds. So now the question is, why do we have query running for 12.4 seconds out of 8 seconds? And the reason is because we have multiple cores. There's parallelism. It's not just one core. So if a query uses 4 cores to run, and it runs average of 1 minute per core, if you want to calculate the total thread time, it would be 1 minute on each core. That's 4. And then for the coordinating thread, making 5. So that's how they usually calculate them. So it is normal to see that the total thread time is higher than the second sample. That's just what I'm trying to explain. And then the top weight on the server, for this 8 seconds period is CX packet. So now I'm going to explain what this means. Some of us are already familiar with this, but for the benefit of those who are not familiar with it. CX packet, and okay, there's another column here that tells you the category of this wait time. So it is related to parallelism, which is an indication that a query is running on multiple cores or multiple threads, because SQL Server wants you to go faster, and then it would not be efficient for one core to do all the job. So it spreads the workload across multiple cores so that the query can go faster. So there's a setting in SQL Server that manages or coordinates this parallelism, which is the max stop and the cost threshold. I don't want to dive deep too much into that, but max stop is just the maximum degree of parallelism, which is how many cores a query would use when it runs in parallel. The default setting is 0, which means a query, when it's going in parallel, running in parallel, can use up to the maximum number of cores on that server. In my case, I have 4. So if I have a query running in parallel, that query can spread the workload across all 4. And then the drawback of that is that when you spread the workload across all 4 cores, you also need to gather the result from all the 4 cores to present to the end user, right? So sometimes the overhead of gathering those results forfeit the benefit of parallelism, because it costs more to gather the results from many cores compared to having the query run on those cores. So that's why we have to set the max stop and the cost threshold to reasonable values in order to take advantage of parallelism. And that will come, we're going to talk more about that when we get to server tuning. So what this means, this column right here, wait time, means based on this wait type, CX packet, query waited for 4.3 seconds out of these 8 seconds that we sampled. Okay. So I'm going to explain more about wait type so that the prospective DBAs will understand more. It's just different hindrances or bottlenecks that a query experiences right from the time of execution to the end of execution, to the time the result is displayed to the end user. Let me use a real life example. As humans, if we want to go from point A to point B, let's say I want to drive from my house to, let's say, Walmart. There are a lot of things along the way that could delay me and not make me get there on time. The same thing applies for query. From the time a query has been executed to the time we finish, there's a lot of things that could cause delay for that query. And those are the things that we call the wait type. So let's come to the real life now. I want you guys to type in the chats. What are the things that you think can cause delay for me when I am moving from my house or driving or walking from my house? What are the possible things that could cause delay for me when I'm uh, driving from my house to, let's say, Walmart? I'll read your response out. Don't worry, just type in the chat. Somebody said accident. Traffic lights. Yep. Road blockage due to construction work. Yep. Yes. Construction work, car issues, if a tree falls, ice check. Yeah, I'm not there. Ice checkpoints, cops, they pull you over, how fast you can walk, and all of that. Yeah, there's a bunch of them. Stop sign, people, zebra crossing, in case you want to buy gas, there are different things that could affect you when you're going from point A to point B. The same thing for a query. When a query, during execution, a query can wait for different resources, and that would lead to different waits. So a query does not experience only one wait from the time of execution, from the beginning of the execution to the end. No, you experience multiple waits. So at a point, it might be waiting for storage, for the data page to be pulled from the storage. That's one wait. At the point, you might be waiting for the database to be pulled from memory. That's another. At the point, you might be waiting to get on the CPU. That's another. At the point, it's just a lot. You might be waiting for 10 dB allocation. That's another. So it's a bunch of different waits. But SQL Server accumulates all these weights together for different queries, and then the one that has the highest weight will be the top. So in the case of my server, when you run this on your server, it might be different for you. So FYI, but in the case of my server, my top weight is CX packet. And this just means that I don't have the right setting for my max stop and my cost ratio. It's just as easy as that. I don't have the right setting. And because I have not altered it, I'm using the default, which is not recommended. And I left it like that, just so we can demo this. So the default setting for max stop and cost ratio is not recommended. I believe there should be like okay. I think there's a URL somewhere that you can read more about this, what values to set this to, and all of that. But we'll talk more when we get to server tuning. So the next wait type here is SOS scheduler yield. This is related to CPU, as you can see here under this column. So queries are executed on the CPU, right? That's the central processing unit of a server. That's where the queries get executed. So when queries, assign a particular CPU thread, what happens internally is that the query will be executed for 4 milliseconds and then yield that CPU for different reasons. One of them could be if it's waiting for another resource, maybe it's waiting for a data page that it wants to write to or read from. Or once that 4 millisecond elapses, it has to yield for another query to jump on, you know, the CPU thread. I like to use the example of, let's say you go to Starbucks and you go to that part where you have to place your order, right? Once you place your order, they will tell you to excuse yourself and wait for the order. That means you're yielding for the next person to come and place their own order. And then when they place their own order, they have to yield too for the next one. So the same thing applies to queries when they are using the CPU. No query will stay on the CPU forever. No, they spend 4 milliseconds, yield, get what they want, get back on the CPU, yield again until the execution finishes. So when you have this SOS scheduler yield wait time, it means that a lot of your queries, and here, this 0.9 means that out of these 8 seconds, queries are yielding are waiting to jump back on the CPU for 0.9, which is not bad because my server is bored. It's not a production server. It's not a production server. If it was a production server and there's a high workload and there's a performance problem, this number will be high. Okay. So to fix this, it means that there are some queries that needs to be tuned. You need to identify queries that are using a lot of CPU. That's how you can tune or minimize this wait. So for the most part, we do not completely eliminate a wait type when you're doing performance tuning. You will not be able to completely eliminate it. Rather, you want to reduce the amount of wait time. Because some of these wait time are necessary, whether you like it or not. As long as you have parallelism on your server, you will always see CX packet. It might not be the top one, but it will always be there because queries are running in parallel, given your max stop setting. So it's not that bad, but you just don't want it to be too long, right? Just in the case of human being, when you're traveling, stop sign is not bad, traffic light is not bad, but you just don't want to stay long at the stop sign. You don't want to stay too long at the traffic light. So it gets bad when it's taking too long. That's when you begin to get cranky. Okay, then the next one is called memory allocation. So this is related to memory, obviously, very descriptive name. So it means that queries are waiting for memory to be allocated. So when a query is running, it needs resources to run. It needs storage, it needs memory, of course, it needs CPU. And sometimes query needs network when, between the application and the database, they need to communicate. They usually also require network, like internet. So those are the basic resources that every query would need for execution. So it means that queries are not getting enough memory, so they are waiting for memory to be allocated to them. And that's why you would get this wait type. There's a bunch of, I don't even know all of them. Trust me, I do not know all of them. I just know the common ones. This one, I've not even experienced this one before. So, but the page latch, this one now, it has to be the buffer latch. This is related to TempDB. Means that, queries are waiting on the TempDB because there's other queries using the TempDB. So there's contention on the TempDB. And we have best practices on how to configure a TempDB, which we will discuss in server tuning. This preemptive is usually due to monitoring tool, if you have monitoring tool. And then this one is also related to memory. Write log means when you're, when you're writing transaction, when the engine is writing transactions to the log, it's experiencing some slowness. And this is usually because of storage, because the log file is on the disk, right? So that's a storage related wait. So if you look at all of these, is that the wait is related to CPU, or is related to memory, or is related to internet network, or the one that is not here, the network one is not here, it's called async network IO. There's a lot of wait types. There's a lot of them. So that's why you want to read the URLs to understand them as you encounter them. All right, so I usually do not focus on these other columns here. There you go. Sorry, my computer is just freezing on me. All right, I usually do not focus on some of these columns, but this is also a good column to focus on. It tells you, so by this, you can actually use it to calculate the number of calls on a particular server. This is this wait, okay? This wait now per call per second. We already know that this is 4.3 seconds. So, but how much of these does every call, wait on is 0.1. And if you do your math, if you're very good, you can be able to calculate the number of cores on the server if you don't already know that. I don't usually focus on these and these. Then this is also a good one, number of waits. So this is how many times this CX packet wait has been experienced in that 8 seconds. 42, and then the other ones, this many number. And then this URL will tell you more about these waits. So let me just copy one of these, pull up the browser. I was supposed to do YouTube Live, but this was how I learned all of these things by reading these URLs over and over and over. So they are very helpful. They tell you more about CX packet, and now you can minimize it. And there's different durations of CX packets. See, there's CX consumer, there's CX sync port, there's also exec sync. All those are related to parallelism. Okay, all right, let's move. So when you come down, the third result set is about storage. It tells you about your storage and what slowness you're experiencing on your storage. So right now, the only slowness is coming from the 10 dB log, and this is the amount of slowness in milliseconds. So we're waiting on this storage for 1 millisecond. And this is the number of reads and write and blah, 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 blah. Okay. So you will usually get a lot of results here if you have storage problem. And then the last result set are just some performance monitor counters. Here, I don't usually use this. The only thing that I check here is just the batch request per second. There's a bunch of here. So if you scroll down, you see that batch request per second here. It gives you an idea of how much workload, see, you have on your server. You have on your server at that time. So for sample time, when you sampled it, this was time, the value you got is this, and then the last time it sampled is that, and then the last value is that. That way you can have an idea of how much work the server is doing within that time. And then this is the difference here. So for the batch request per second, let's focus on that. Where is it again? Oh my God. Okay. Within the 8 seconds period, it says 90. Yep. I don't know how it came about 90 because there's nothing running. Or maybe it was the one already ran earlier. All right, let's proceed. I think I pretty much explained all the ones that I use for the most part. And then this output tab is just to list only the top weight, only the top 10 weight tag for you. You can practice this on your own, so we don't waste time here. And just like SP Bleach, you can also save the result of this start procedure into a table, to serve as your benchmark or baseline. So because if you run this with expert mode, as you can see, I have different result sets. I have one result set for performance counter, one for storage, one for wait stats, one for active queries, and all of that. So that's why we have all of these. You put them in different tables for you. But you can choose, if you don't want all of them, you can just say this is the one you want. Maybe you just want the performance stats or the wait stats, then that's the only one you would put in this query and run it, and it will save it for you in that table. It will persist on your disk. All right. Any questions about Bleed first? So a quick recap. SP Bleed is to check the overall health of your server. Just like annual checkup that we do, SP Bleed first is to check real-time performance or health of your server when there's fire on the mountain, just like when you get sick and you need to go to the urgent care or emergency. Okay? There's a question here on a production LCP with 8 cores and 111 gigabyte of memory. What would be the recommended max stop setting? Core load is currently set to 25 and the max stop is set to 0. So yeah, which means you're still using the default value for the max stop. Obviously bad practice. So according to Microsoft's recommendation, you want to set your max stop to half of the number of CPU cores you have on that server, depending on the Newman node configuration and all of that. But let's say you have 8 cores, which you do have based on your question. You want to set your max stop to half of that, 4. And the implication of that is that instead of a query to run on all 8, you want to limit it to run on just 4. And then leaving the other 4 for other queries. So that way you're able to manage parallelism very well. And then for the cost threshold, there's no one value fit all. You just have to play around it. Of course, change it from the default, but play around the value based on how your server is performing. 25 is not bad, but if you notice that you still have high parallelism weights, you might want to increase that a little bit. And the point of or the purpose of increasing your cost threshold is because you're trying to reduce the number of queries that would run in parallel. Okay, because the lower the cost threshold, the more queries are eligible to run in parallel. The higher the value, the less queries will run in parallel. You want to make sure that only queries that are very expensive take advantage of parallelism. You don't want a query that's not expensive to just be running on multiple cores. It's just a waste of resources. So, but everything still depends on approval in the production environment. If they don't want you to change it, then you just got to leave it. You have to say your own recommendation as an expert, but you can't push too much. Okay, so let's move to the next one. Okay, you know what? Let's take a quick break. Let's take a 10 minutes bio break, and then we'll come back. So I'm going to see you guys in 10 minutes. Let me set the timer. Oh, it's going to, oh, sorry. 103.
ìjẹ́ kọ́ lọ lórí fóònù lẹ́yìn gbà yẹn dàní. Mo tún ṣe káàtì tó dúró náà kí n bí ètò ìwọ̀n ti wà lórí fóònù.
All right, welcome back. Hope you enjoyed the bio break. Yeah, so I saw your questions. Unfortunately, you can't pause the recording on Teams, unlike Zoom. So that's why I left it on. But when you're watching the recording, you can just fast forward the break time. And then someone asked, can the max stop be changed at on query on database level? Yes. So you can change max stop at the instance level. You can change it at the database level. You can also change it at the query level. So if I want a query to run fast, I can say, at the bottom of that query, I'll put option maxed up equals the number of cores I want that query to run on. So that's very much possible. All right, let's proceed. So far, we've been able to diagnose our server for overall health. We've also been able to um, find the real-time performance bottlenecks on the server. Now, the next thing for us is to find those queries causing these bottlenecks. And in order to do that, it would leverage another stop procedure in the first responder kit known as SP underscore bleed cache. Okay, so bleed cache is used to find the top resource consuming queries on your server. In other news, the queries that are causing those bottlenecks that we identified using bleed first. Because without any query running on your server, you probably don't have any, there will be no, what is it called? Bottlenecks or anything. So every slowness in the database engine is associated with a particular wait type. Okay? Every slowness is associated with a particular wait type, and every wait type is caused by a particular or multiple queries. You can clock it. Let me say it again. Every slowness in the database engine is caused. I forgot what. Every slowness has an associated wait type. Okay. You can attribute every slowness to a particular wait type, and every wait type is caused by a particular query or set of queries. Lock it. All right, so let's find those queries that are causing the slowness on this server. So let's start by finding or checking what parameters this dot procedure takes. By running this, yeah, we expect to find a lot of them. So let me just scroll down. Yep. So there's a bunch of them here. And again, you don't have to know all of these, memorize them. You probably won't use all of them throughout your career, but there are some of them that are very important to know that you would need. And I'm going to share those with you. But one thing that is common to all of this stored procedure is the at one parameter that is common to them is the at help, which helps if you have any questions or about the stored procedure is going to provide more shed more light on each stored procedure for you. This at help, and the the type is bit, which means the value can either be 0 or 1. By default, it is 0. And if you want to know more about the stop procedure, just set it to 1 and then run it. It will tell you more about the stop procedure. Okay. All right. So now let's see how we use those parameters. So by default, if you run spblit cache, it would give you the top 10 resource consuming queries. By default, it's going to give you top 10. However, you can ask for top 5. You can ask for top 15, top 20, but default is 10. And then by default as well, the resource that your queries are bottlenecked on is CPU. So if you don't put any value for the sub order, it's going to give you queries that are bottleneck on the CPU, which means queries that are causing slowness on your CPU. That's what it'll give you. However, you can change it in case you don't have a CPU problem. Okay? It's not every time you have a CPU problem. Sometimes it could be, like I mentioned earlier, it could be memory, it could be storage, it could be network. But by default, it's a CPU. And we would, so the resource you want to put here would depend on your top weight that you identified in the bleed force. So all of these top procedures, they kind of like depend on each other, pretty much. All right, then expert mode is just to give you more information as an expert that you are. And then at minutes back means you want to go back to find queries, top resource consuming queries that were executed a certain minute ago. In this case, 90. I don't think you can even go beyond 90. I think the maximum is 90. And then the output type is just to give you the top 10 weight type. Wait, is this supposed to be here? I have to double check that. And then the last one here, stock proc name. So let's say instead of finding top resource consuming queries, you just want to focus on, or let's say they ask you, oh, please, this start procedure is slow. Can you please look into it? They've narrowed it down for you. So you don't have to be looking for resource consuming queries because you already have the query that they've identified as the problem. So, and if it's a start procedure, you can use this parameter to narrow it down to help you find, what the problem is in that stop procedure. It's specific to that stop procedure. But like if you run it like this is generic. It finds you all kinds of queries, stop procedure, functions, everything like that. Okay. So I'm going to run this as is, just so we see, without using any parameter. Feel free to put your question in the chat window so I can answer while we are waiting on the query to finish. Didn't even ask if you guys can hear me after the break. Can you guys hear me? Please just tell me yes or no in the chat.
Yes.
Yes.
Okay, thank you. All right, so now we have the top 10 resource consuming queries based on CPU. Remember, that's the default. If I scroll down, you see that these result sets should have 10 queries. No more, no less. See? Because that's the default value. But like I said, you can always change it if you don't want up to 10 or if you want more than 10, you can change it. But let me tell you how to interpret this result. So the first column, the first result set here, you have two result sets here. Yes, two result sets. The first result set, or the top one, the first column of the first result set tells you the database in which the query that is, the top resource consuming query is executed or was executed. So if you see, you have different queries here. I mean, different databases here. I have Stack Overflow. I have SQL repository, and I think those are the top. Yeah, just those two. So, and then the second column tells you the costs of those queries. And then the next column tells you the text of those queries. If you look at this one, is a create procedure query. The same for these, the same for these, but this one is a select top 100 query. This one is an insert query. You know, it like that. In your own lab or at work, it's going to be different. It depends on what query you guys are running. So under the query type, this is where it narrows it down for you to know what procedure it is. Pretty much. So this is this procedure. These are the stored procedure that I was running from the SQL Stress tool. And then this database is the database for the second monitoring tool that I'm going to be sharing with you. So the monitoring tool is basically running some DMVs on the database to capture metrics to display to us, which we will see shortly. I'm trying to wrap up this as fast as possible so we can go watch the Man City game. Some of us are determined to see Man City fall today. All right, so then here, this column, this is one of my favorite columns. So this is where it tells you the problem or what is wrong with that query. And a query can have multiple problems. So here, for this top query, or for this first one, it says it's running in parallel. That's a problem. And remember that we identified CX packet as the top weight, which is related to parallelism. So that's consistent. Another problem that the plan that this query is using was created last 4 hours. And then there's also table variables. And if you want to check the plan of that query, you can click on this XML, then it will show you the query plan of how SQL Server is executing that query internally. I'm going to jump into this one. The problem with this query is that there's compilation timeout. So when it is generating the execution plan, it times out. And this often happens when the query is complex. Yeah, it will time out. There's a certain milliseconds to generate execution plan. Once it's unable to generate within that time, it's going to time out. So that's one problem. Another problem of this query is forced serialization. Serialization means it is running on one CPU core or thread instead of running on multiple, because I have parallelism set on this instance, but this query is not benefiting from parallelism. And if I go back to the column that says query cost, actually the cost is small, so you don't expect it to run in parallel, but it is being forced. So the thing now is it is being forced to run. It's not just running on one single core, it is being forced to run. This happens when you have some, let's say, functions in your query. If you have some user-defined functions in your query, especially in the where clause, on the left-hand side in the where clause, that would force your query to run serially, even when it is supposed to run parallel. And because the column that is enclosed in that function has been blindfolded by that function. So it forces it to run serially, and it makes that column to be non-taggable. As you can see here, there's non-taggable here. Makes it to be non-taggable and not take advantage of the index. So let me explain non-taggability. So probably, should I wait till index tuning? Okay, so when we create an index, we expect that the index will help us to retrieve data based on the columns in that index quickly, because the index will sort the data based on the columns. So, but when we put, let's say I have an index on the first name column, and then it sort the first name alphabetically. So when I write a query and I say where first name is Adewale, I expect it to dive right into where Adewale is and fetch it for me, and let it go fast. But if I put a function around You know what? Let me go into drawing mode and draw this so that would make a lot of sense. Draw mode. I always forget these things. Control 2. Okay, and I think if I do Control T, I'll be able to type. So let's say I have this query. Select star from let's say the table name is students, where first name equals Adewale. I say this is my query, and I already have an index on the first name. That index is expected to make this query run fast, right? Oh, but if instead of this query like this, we have this query, select star from students, where, so instead of putting the column name, I put a function. Let's say upper first name, equals Adewale. So the difference between these two queries is that in the where clause, the first two lines are pretty much the same. Select star, from student. Then the third line, that's where the difference is. Here, we have where the column name, in this case, the first name equals this. But here, we do not just have the first name, we have a function here that is taking this first name as a parameter. So this function, this is a system function. It's not a user design. It's a system function. So either it is user defined or system, they do the same thing as long as it's a function. So this function will make this query not to use the index that has first name to fetch for Adewale. You know why? Because this function will have to come to apply to every row in the first name column. It has to convert them to first name, to uppercase, in order to fetch which one of them is Adewale. So because of that, it would not let this query benefit from parallelism. So it is going to force this query to run serially. That's where we have forced serialization. That's one. Another thing with forced serialization is that because this query cannot use the index on the first name, so this function is making this column to be non-searchable. Searchable means searchable argument. So this query cannot benefit from that index because it has to run across every row in this first name. So the index is pretty much useless as far as this query is concerned. So that's that. I hope I've been able to explain that very well to you. Okay. All right. So the next query here is going in parallel to, there's an expensive sort operation, which means there's probably order by in the query. So order by is very expensive. It requires additional memory, to sort those records or results. And then you see that pretty much they have the same stuff. There's long running with low CPU. This is usually caused by blocking. A query that's experiencing blocking would have this warning. Table variable, because table variables, you cannot update the statistics, and then some other limitations, they usually pose a problem. That's why it is here, and the likes like that. So here you can check the query plan for those queries. prior to 2019, you would only see estimated execution plan here. Estimated execution plan. If I click on it, it should show me the estimated, not the actual. And you agree with me that estimated is not really that, great. Is a good start, but you don't have all the information you need on an estimated plan. Oh, I hope my SMS doesn't crash. Ooh, it's gonna crash. Oh, thank God. Yep. So this is the execution plan. So and how we read the execution plan is from right to left, top to bottom. So you read it like this. Oh, yeah, we go this way. I don't know what's wrong with my. Yeah, we read it like this direction. Yep. And then we look for the operator. So each of these is called an operator. You can look for the operator with the highest cost, and that's where your problem is coming from. And it looks like it's this one right here, 51%. This one. All right, but that's not the focus of this, so I'm gonna cancel. And then this column provides information of any index that would benefit this query. If there's any implicit conversion, it lets you know, but there's nothing here. That's why I say there's no need to click me. Implicit conversion is another common performance bottleneck that some queries experience. And then as I scroll to the right, it tells you how many times that a particular query has been executed since the last time the server was restarted, how many executions per minute, how much time is spent on CPU, because it will spend different times on CPU at different times that it was executed. So that's why we have this average here, just to give you an idea. And then how long it took to complete, how many pages were read during execution, how many writes were done, how much memory was granted to the query, and then if there's any spill to 10 dB, the time the stop procedure was created, when it was last executed, when it last completed, and blah, 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 blah. Okay? All right, so that's the first result set. And then the bottom result set now tells us, so each of those warnings that we saw above, this is where it breaks them down for us. It highlights them here and then gives us URL to learn more about those warnings. So these URLs are very good if you want to, focus on performance tuning. You want to go to each of these and read them and digest them. We'll let you understand all of these better. That's how I got to learn them as well. So if you want to learn about non-stackability, implicit conversion, expensive sorts, trivial plan, table variables, blah, 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 blah. It provides you more insight on about the problem and how you can fix them. And then there's a detail column here to tell you more about it. And then there's a priority here. Remember, we want to focus on the ones with priority 1 through 49. Okay. Any questions? Please drop in the chat window. So this is how we would identify those queries that are causing the bottleneck, depending on the top weight that we have. So, okay, I already discussed this one. If you're focusing on a particular stop procedure, just provide a name and then run it. It's going to tell you all the problems or warnings of that stop procedure, and you can go ahead and fix them one by one. So for the sort order, I mentioned earlier that the value you want to put for sort order depends on your top weight that you identified in the when you ran bleed first. By default, it's CPU, but you may not have CPU problem as your top weight. So this breaks down what value you should sort by depending on the top weight that you have. So if your top weight is CX packets, CX consumer, or large X, you want to sort by CPU, which is the default, and then you also want to sort by reads. Because what this means is that when a query is running in parallel, it means is that it's doing a lot of work and it needs multiple cores so it could finish the work on time. So it's reading a lot of pages from the, it's reading a lot of pages and it's processing those pages. So it's using a lot of CPU and then reading. So that's why you want to start by CPU and then sort by reads to identify those queries that are causing these top weights. But if your top weight is LCK, which means lock, okay, let me explain. So CX packet and CX consumer are both parallelism weights. And I think it depends on your version of SQL that will determine which one you get. If you are using prior to 2016, you won't get CX consumer. You only get CX packet. But 2016 or later, you start seeing CX consumer or the other one that I showed you earlier. And then large X, this is a weight type associated to when the engine is reading a lot of pages from the buffer pool. And you're reading a lot of pages, and you have to wait, because there's a lot. And the other queries are also pulling from memory as well. So that weight is called a large X. The EX is exclusive, which means is reading it from the buffer so you could write to it. So when you see SH, it means it is shared. It means it is reading those pages or waiting to read those pages so it could read those pages. But when you see EX, it means it is reading so it could write. It is waiting to read them so it could write them, make changes to them for when you're running delete, update, or insert statements. LCK means blocking, which means a particular query has placed a lock on the resource, let's say table, and then other queries are waiting for the lock to be released so that they can read data from the same table. And, so if you have LCK as your top weight and you want to identify the query that is causing the LCK, you do not want to sort by CPU. You want to sort by duration because blocking makes the query to run longer than expected. So you want to find those queries that are running for too long or long-running queries. Those are the ones causing your LCK. If your top weight is page IO latch, unlike latch EX, so we also have page IO latch SH, page IO latch EX. So page IO latch means that you are waiting on storage to read those data pages into the memory. So this is because the data that the query needs is not available in the buffer pool. It's not available in memory. So you have to go get it from the disk. So, and the disk is either slow or there are other queries reading from the same disk. So you gotta wait. Let me make a quick scenario of how this works. I try to relate how the engine reads from disk and memory to the kitchen. In your kitchen, you have your stove, right? And then you have the pantry. And then you have your favorite grocery store that you go and get your groceries. So think of the grocery store as your disk, like the permanent storage. Your grocery store is the disk. Your pantry is the memory. And then the stove where you cook is the CPU. So when a query is being executed and it needs data pages or data to process, the first place it checks is the memory. The same thing for you when you want to cook at home. Where will you check for the food or the grocery you want to cook? You want to check the pantry or the kitchen cabinet, right? To see if that food or whatever you want to cook is available. If you cannot find it in the pantry, what would you do? You order from the grocery store. Either you go to the grocery store yourself or you do Uber or Instacart. Yeah. So the same thing applies to the engine. If the data page it needs is not available in the buffer pool or the memory, then he has to go to the disk to go grab that page. So when he goes to the disk, he grabs the page and then caches that page in the memory. And then the CPU will then read the page from the memory, which is similar to what we do in real life. You go to a grocery store, buy groceries, put them in the pantry. When you're cooking, you grab from the pantry. When it's finished in the pantry, you have to go to the grocery store again, buy, put it in the pantry, start using them. When it finishes, it continues like that. So when the engine or the query is waiting on reading pages from the storage, it experiences what we call the page IO latch. So it's waiting for pages because of input output from the storage. But for latch, the pages are already in memory. But because we are reading a lot of them, it will take some time. And because other queries are also accessing the same memory, you experience some delay or wait. So that's when you say latch. So page IO latch is from storage to memory, then latch is from memory to CPU. Resource semaphore. Okay, so now if you're experiencing page IO latch as your top weight, you want to sort by reads because you're reading pages. So you want to look for queries that are reading a lot of pages. Those are the queries that are causing this weight stat or weight type. But if your top weight is resource semaphore is a weight type associated to memory as well, just like the memory allocation extension that we saw earlier. Resource semaphore means your query are waiting on memory to be allocated to them, because every query needs memory. So if there's no sufficient memory yet, it would wait. It will use the CPU to wait for memory. So, which is an indication that you don't have sufficient memory on your server. So if you are having that wait type, you want to sort by memory grants. That's how you would be able to identify those queries causing the resource semaphore wait. You don't want to sort by CPU because you don't have a CPU problem. You have a memory problem. So you want to sort by memory grants. Someone is asking, what is the fix for page IO latch? You want me to let the cat out of the bag? That should be for episode 2. Yeah, that will be under index tuning. We'll talk about that when we get to index tuning. But let me just quickly answer that. So when you have to go, just like I explained earlier, SQL Server checks the memory. If the data page is in the memory, it goes to the disk, right? So now what's the solution? Is to make that page be available in memory. How can you make it available in memory? If you create appropriate index, it will be easier for the page to be cached in memory. And of course, your memory has to have a sizable amount too. So having appropriate index and having a reasonable amount of memory will fix your page IO latch for you. And I'm going to demo that when we get to index tuning. So SOS scheduler yield, I explained this earlier, when queries are yielding CPU because they are waiting on resources or letting other queries jump on the CPU, because that's the CPU problem. So in order to identify queries causing this wait type, you want to sort based on CPU. Then here, write log, wait type associated with writing transaction to the log. And then HADR sync commit. This is a wait type associated with when the primary replica is sending transaction to the secondary replica, and then you're waiting for the secondary replica to commit those transactions. If any of these is your top weight, you want to sort by writes, because that's what is causing there. And this is common if you are using synchronous commit mode, because synchronous commit mode would make the secondary to commit the transactions first before it commits it on the primary replica. So if those servers are far apart, or the network signal is bad, there will be some latency, and then you will experience this. You don't get to see this if you are using asynchronous, because asynchronous will just send it to the replica, as it pleases. So you don't experience this wait. So a quick fix to that is to change to rep to asynchronous, or check what is causing the delay on the secondary replica and then fix it accordingly. Maybe the resources is not enough and all of that. I believe that is the end of bleed cache. Yep. So this is how you will identify your resource consuming queries. Any questions? All right, a quick recap. SP bleeds, find the overall health of your server. Bleed first, find what is wrong with your server right now and identify the top weights. And then bleed cache, based on the top weights, you want to identify those queries causing that or those top weights. So in the case of my server, what is my top weights? When I run bleed first, let's go back. When I run bleed first, I want to see if you guys are paying attention. Maybe there will be a gift card to whoever gets this question correctly.
CX packet.
My ECS packet, right?
Yeah.
Can't even find it. Everything is just doing is blurry. Oh. I think it was CS packet, but I can't find it. Okay. I have to scroll to the left. All right. Yeah. My top weight is CX packets. And then my next one is SOS scheduler yield. So based on what I explained earlier, what would I use to sort using bleed cache to identify the query that is causing CX packets? Just type the answer in the chat window. Yep. Because my top weight is CX packets, I want to sort by CPU, and then I will sort by reads. Because the queries are using CPU to run in parallel because they are reading a lot of pages. If it was just SOS scheduler yield, or if SOS scheduler was my top, then I'll just need to sort by CPU only. All right, good job. You guys are following. So let's now go to the next. So now that we've identified the query that is causing the top weights, sometimes the query will require indexes to make them run faster. So that takes us to the next stock procedure, which is SP_bleed index. Are we doing on time? Okay. So SP_bleed index is a start procedure in the first responder kit that is used to perform in-depth index analysis. You can use it to perform in-depth index analysis on the entire instance, which means all the databases on that instance. You can focus or narrow it down to just a particular database on that instance, or you can narrow it down to a particular table in a certain database. So if you run this, you see all the parameters that it uses is a lot, as expected. But how do we use them? So if I run this as is without putting any parameters, this will give me index, it would perform index analysis based on the database context, the database that I'm connected to, which is the master. You will focus on the master alone if you're running without any parameter. And of course, I'm not interested in tuning who creates index in the master database, right? So you see, there's no major problem found because we create the index in the master database. But if I want you to do index analysis on the entire instance, which is all the databases on that instance, then I'm going to give this parameter, get all databases equals 1. is going to perform index analysis on all the databases up to 50 databases. What if you now have more than 50? I think that's when you use this parameter, bring the pain to 1. But I don't even have up to 10 databases, so you're good on that. So I'm going to run this now. So what this does internally is to run some index DMVs to capture some metrics about indexes, how they are being used and all of that, and then displays that to us. So while this is running, let me talk more about the other parameters. Another important parameter is the mode parameter, which I will expatiate more later. And then we have the database name. So this is where you use this if you want to focus on just a particular database, not all the databases. You want to focus on a particular database, you give the name of that database. And the schema name usually goes with when you supply the table name, because every table will be in a particular schema. So if you want to focus on a particular table, then you have to supply the table name. By default, it would assume that that table is in the DBO schema. But if the table is not in the DBO schema, you have to supply the schema name. If not, it will tell you that it doesn't exist. Okay. All right, so the results set is out. And then what this does is to give us all the indexes on all the databases on that server. So what it does is it itemizes or prioritizes these indexes based on what Brent called the depth method. D for dedupe, which means you have some duplicate indexes that are pretty much doing the same thing because they have the similar columns. So as you can see here, okay, the first problem here that we're seeing here, which is priority 10, says that we have too many, NC means non-clustered. We have too many non-clustered indexes on one table. And if you come to this column, it says there are 12 non-clustered index on this particular table. Of course, that's a lot, right? So if you scroll to the right, it tells you how the index is being used. So they have used the indexes to perform read operations 26 times, and they are written to those indexes to almost 2,600 times. I'm going to talk more about usage later so that you can identify useful and useless indexes. And then this is the size of the index. And as you scroll further, this query is what, if you now want to dive deep into this particular table, you want to use this query to narrow it down to that particular table. And if you want to learn more about having too many indexes, go to this URL to learn more. And then as you scroll to the right, it provides you a query to create that particular index. The reason for this is because let's say you want to make a change. You find out that these indexes are too many, and you want to drop them, but you want to have the create index query on the side for rollback. In case your manager says, "Oh, why did you drop them? Queries are running slow now." Then you want to roll back and create them again. That's why they have that right there for you. Okay. All right. The next set here are duplicate keys or duplicate indexes. Indexes that have similar columns. They're pretty much redundant. So one of the things that we do in index tuning is to identify those duplicate indexes and try to dedupe them, like reduce the duplicates, because they are doing pretty much the same thing, but they're taking up space and they're making operations such as backup, restore, delete, updating, so they're slowing those operations down. An index is supposed to benefit read operations, select queries. If it's doing anything other than that, then that index is not optimal. So these indexes, this is the name. So this column tells you the name of those indexes. And then this column tells you the columns in those indexes. Some indexes have included columns, some do not. But if I expand this, you'll see that, okay, yeah, see? So they have, every index would have key column and may or may not have the included columns. So the key column are what is used to sort the records, and then the included column are just there, you know, just to prevent key lookup. Okay, we'll talk more about that when we get to index tuning. This column is just telling you the columns that make up that, you know, particular index. And then this one called the secret column, this is the column of the clustered index, because every non-clustered index points to the clustered index on that table. You can only have one clustered index per table. So, but you can have multiple non-clustered indexes up to like 99 per table, and each of those 99 will be pointing to the clustered index using the clustered index key. So that key is this column right here. Okay, that's why it's called secret column. So that's why they say that every non-clustered index has clustered index inside of it. So it would be redundant for you to want to create a clustered index and then include the column that was used to create the clustered index in the non-clustered index. You don't need it because it's already there. And then this column tells you how these indexes are being used. So you have two parts. You have the read and the write. Like I said earlier, the benefit of, or the purpose of creating an index is to help for read operations, not write. Is to help read operations. So an optimal index supposed to have higher reads than writes. You're supposed to be using it for read operations more than you are writing to it. But if the reverse is the case, that means the index is not good enough. You know, so it's just like you you have a car. Let's say you bought a car. The purpose of you buying the car is for the car to transport you from point A to point B, right? You want to sit down and drive the car. But if the car keeps, having fault, and now you are the one pushing the car, you are the one driving the car instead of the car driving you, then the car is useless, right? So the same thing for the index. So look at this one now. This index has not been used to read any query. Zero reads. But we have written to the index 496 times. And you only write to an index every time you change data in the table. If you do delete, update, or insert on a particular table, and you alter the data in the columns of that index, you have to do the same thing. I mean, if you have to do the same thing on the index to update that index. But this is a very good one. This one that just highlighted. See, it's been used to read query 15,000 times, and you've only written to it 496 times. This is how you know this is an optimal index. You are using it for read operations more than write operations. This is also a very good one. Which one again? Yeah, but these are not really that good. So read it, you use it to read once, but you're reading through 216. Because write operation will slow down performance. Okay? All right. Okay, I've talked about this already. And then as we go down the priority list, we are leaving the duplicate ones. And then the next set of index you see, they are the ones that are missing. So SQL is telling us that based on the query that you're running, this index will be beneficial to those queries. But these indexes are not available, they are missing. So this is like the engine giving us index recommendation, like you should create these indexes. But there's a caveat. do not just grab the index and go and create, because there are some concepts that you need to understand when it comes to creating indexes. You don't just follow SQL Server blindly. Okay. Okay. Then the next step, if I go down, it tells us that there are some tables with no clustered index on them. And a table without a clustered index is called a heap. And that's not good for performance, because heap causes forward fetches. If a table does not have a clustered index, it can make the data on the data pages to span across multiple pages. And then when the engine has to go read them, you have to go and read them across multiple pages. So it has to fetch them forward. Instead of reading everything in one page, you have to go across maybe 3, 4, and that will slow down performance. So that is why it is encouraged to either rebuild your heap table or create a clustered index on them to compact it. Clustered will compact it, and the engine will not have to do forward fetching, because forward fetching is expensive computationally. And as we come down here, we have a heap table with a non-clustered index. That's what it says, which is not bad, but there's probably the non-clustered primary key. Yeah. So we'll talk more about all of these. I'll get to forward fetching and index scanning. No, they're not the same. Index scan is when SQL is using the index to scan, the table is scanning the index for the data that you're looking for. For forward fetch is when you are reading across multiple pages while you're looking for it. So it's like you are doing forward fetch while you are scanning. Yeah, but they are not exactly the same thing. So you are scanning, but you have to scan across multiple pages instead of just one page. Okay. So this is how we identify issues with indexes. But I don't like to do this because it's too, it's too much noise here. I like to narrow down to a particular. So this is how I narrow down. So if you come here, based on this, you can identify the database that has the most, problem or index problem here based on how many times it occurs or appears here. And then you can begin to focus on that particular database. And you can also identify a particular table too that has the most index problem. So because for the purpose of this series, we're going to be focusing on the Stack Overflow. And if you look at the Stack Overflow database here, most of the index problems here are coming from the post table. See? So we're going to focus on the post table. There are other tables in this database, but the post one is the one that has index problems. So that is how I narrow down where I want to focus on. So now to focus on that, I'm just going to grab this parameter. I don't need this parameter anymore because I want to focus on a specific database and not all the databases. And I want to focus on a particular table. So because I know that the post table is in the DBO schema, I may not put the schema name there because DBO is the default schema. What's wrong with my mouse? Oh. I'm just going to put it there, that to be saved and sorry. All right, so we have the fully qualified name here, database schema table. So now it's going to analyze all the indexes on this table for us. Maybe I should have done the mode before, but let me do this, then I'll get back on the mode. So now we are narrowing it down to just the post table. Okay, the result sets are here. So there are like 3 or 4 result sets here. The first result set tells us about the existing index on this particular table, which is the post table. And as you can see, we have just one, which is the clustered index. That's why we have the CX. So this is the name of the index here in the first column. CX means is clustered index, primary key, and then the column that was used to create that index is the ID column of type integer. You scroll across. There's no secret column. Why is that? Who knows why there's no secret column for this index? Put it in the chat. Why is there no secret column for this index? Not because there is no cluster index. It's because no non-cluster index. It is because this column itself is the secret column, because this is the clustered index. The clustered index is the secret, the columns in the clustered index are the secret columns for the non-clustered indexes, because the non-clustered indexes point to the clustered index. So a clustered index does not have secret column because the columns, its columns are the secret columns. Few factor, 0 means 100. I don't want to delve into few factor. And here we see it's been used to read query 19 times, written to it 0 times. These upstarts, I do not really focus on this much. But another thing you want to focus on when you're doing index tuning is this guy right here. How long your server has been up for. My server has been up for less than 3 days. As you can see, 2.71 days, which is pretty low. So before you can make any decision on tuning indexes, you want to make sure that your server has been up for a while so that you can have representative sample of these metrics. 2 days is too low to decide what index is useful and what index is not. What if the query that uses that index has not been run in 2 days or 3 days? It is possible. Maybe it's a weekly query. So that doesn't mean the index is useless. So you want to make sure that this is about a month, at least 30 days. So usually majority of the queries on that server would have run within 30-day period for you to ascertain that, okay, these indexes are useful, these ones are not useful. So it's very, very important. Please take notes of the uptime. There's no, this is just telling us the last time the index was used to seek, the last time it was used to scan. We'll talk more about index scan when we get to index tuning. A lot of times it was modified and all that. And then the second result set tells us, so the first one is the existing index or indexes. The second result set are the missing indexes, the indexes that the engine is telling us that we need to create based on the queries referencing the post table. And like I mentioned, don't just go ahead and create them. You want to do your due diligence. Okay, so let me explain what these columns mean. So this column tells us that if you create this index, this is the benefit of this index. It has no units, but the higher the better. Let's just see. So because this is the highest, so it looks like this index might give us the most benefit. And then it's telling us that these are the columns that we need to put in the index that is recommending to us, which means that the queries running have been filtering on closed dates, community owned date, and the other columns here. And then this tells us how impactful this index will be when we create it. It would have been used twice, and it would have had 96.9% improvement on the query performance. And it provides us the the SQL to create that index if we want to go ahead and create it. Okay. And then the last, okay, not the last. The third result set tells us the columns in the post table or whatever table that you put here. There are the different columns in that table, their data types, their length, their precision, and all the other information about whether or not they're nullable, whether there's an identity column or not, it tells you. Then the next one tells you there's a foreign key on that table. Obviously, there's no foreign key. And then the last result tells us about the statistics of the data distribution on that table. Okay. This is also very important. It's also is very important to know how the data in your table are distributed. Uneven data is not good because you'll be experiencing parameter sniffing if you are reading from that table. And then if you scroll to the right, it tells you the last time the stat was updated. And you know that this is very important to update statistics. So you can see 2018. That's a long time ago. So if there's any execution plan generated based off of these statistics, it might not be accurate, especially if I've made some changes in the data. And tells you how many rows of data, how many rows was sampled to update the stats and the blah, 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 blah. So obviously you can see that because the number of rows sampled is equal to the table rows, that is a full scan. You use the full scan to update the start of this at this particular date. But for the last one, you only use this number out of this. So this is a sample scan, not a full scan. And of course, full scan is better than sample scan, but sample scan complete faster than full scan. So it's just a trade-off. You want to trade performance for time, or you want to trade time for performance? All right, so that's how I do this to narrow down to a particular table. Another interesting parameter that I use is the mode. Okay. So when you're narrowing down to a particular table, you cannot use the mode parameter because it uses the mode equals 0 as a default. You cannot use mode 1 or 2 or 3 because mode has different values. So I'm gonna try this with the mode parameter, and I'm gonna take out all of these guys because we are no more narrowing down. So you have different values for the mode. It's from 0 through 4. So mode 0 will just tell us all the index problems, the existing index, it tells us high priority issues with the index on that server. So if I run this, so which of these two columns from the start procedure do you use to decide on index creation? Estimated benefit or estimated impact? Oh yeah. For the most part, I use the impact, but I don't just go off of the impact. I also go. So there's also a relationship between bleed index and bleed cache. Because the point of you creating the index is for the index to be beneficial to the query. So you have to identify the queries first and then look at the text of the query. The best way to know what columns you want to create an index on is to check the where clause of the query, the join clause, the order by. Yeah, those three. Those are the areas where you will know what columns you want to put in the key column of your index. And then in the select clause, then those columns there are the ones you want to put in the included part of, or the include part of your index to avoid key lookup. So I don't just go off of the estimated benefit or or estimated in part, I still have to do my due diligence to find what query, the top query that is causing a problem or that needs index, and find what columns I would use to create those index. So everything is just kind of interwoven. All right, so right now this is telling us, oh yeah, because I didn't specify a particular database, it's telling us that there's no problem. So I'm going to change my context to Stack Overflow and then run this again. Because this is more like a default stuff. Anyways, even if you don't put mode 0 and you run it by this, it's still like you put mode 0 because that's the default. Need to wrap this up. Okay, it still says there's no problem. So let me change it to 1. So what mode 1 does for you is to tell you the number of indexes you have, the size of those indexes, and blah, 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 blah. See? Oh, dang it. It's telling me how to DBA because DBA is where the deleted index is. Okay, I'm going to put this guy. He's running it based off of the DBA database context. I'm interested in this one. What are those factors to consider before creating an index, apart from the server uptime? You want to consider the existing indexes because you don't want to have too many indexes. You can slow down the server. So you want to consider the existing one, make sure there are no duplicates. The one you want to create now is not going to be a duplicate of the existing one. And then if you already have too many, you don't want to create another one. That's one thing you have to do. You also have to look at how are the existing ones being used. Most likely you probably have indexes that are not being used. So you want to eliminate those ones before you create a new one. So that, because if you have too many indexes, it makes your database just unnecessarily big and it slows down performance. And then to create an index, you also have to take into consideration what queries will benefit from the index, and then what order will the columns that you put in those index, what order will they be based on how those columns appear in the query. So you don't just create index, you have to identify the query that needs that index. Based on that, that's how you would determine, okay, for example, there was a time I was working on a query tuning, and the query has join clause, where clause, and I think order by, or maybe not, I'm not sure of the order by, but I know there was a join and where clause. And if you know the order of execution of SQL Server when it executes a query, the join clause will come before the where clause, right? Which means it has to join the tables first before it will even filter the records from the table. And that's why I said you need to check the join clause, the where clause, and the order by when you are selecting the columns for the key part of your index. So I played around with it and I created an index with the columns of the where clause first, followed by the columns in the join clause. And then I created another index with the columns in the join clause, the column they are joining on first, followed by the index, followed by the columns in the where clause. And I try to, just see which one performs better. And as expected, the index that had the columns of the join clause first performed better than the one of it, because the engine would have to join them first before it would filter. So those are the things, and then the order in which those columns appear in the query matters a lot when you're creating the index. For example, when the query I wrote earlier, where you have where first name equals Adewale, let's say there are multiple columns there, where first name equals Adewale, comma, I mean, say comma, and last name equals, so that means 2 columns. So when you are creating an index, you also have to take into consideration how the order of those columns in the query when you are creating an index for that query. That's one. You also have to take into consideration the equality or inequality in those columns. So there are times where they will say they will use equal sign. There are times where they will use greater than or less than. All right. So if you have equal sign in all those columns in the where clause, the order does not matter. But if you have inequality greater than or less than, the order does matter because it gets more selective than the other. The columns are more selective than the other. So you don't want to read 51 million rows just to, at the end of the day, return 5 million, 5 rows. So you want to reduce the selectivity, and then that will help to improve the query performance. Don't worry, we'll talk about that in indexing. Let's quickly run through this to save time. So here, mode 1 tells us that in this database, there are 9 indexes, and then all the indexes put together, their size is 47 gig. And then this is the large objects. I forget what this one is. It's still part of the index, but the LOB means large objects. My server is frozen. And then this one tells you how much time it's been up for. And then out of these 9 indexes, 9 of them are clustered, which means there are no non-clustered indexes. That's what it means. And then see, NC index is 0. There's no non-clustered index. Of course, there's no size for them because they do not exist. And as you go, this is just to get you familiar with the index on that table. It's not entirely useful or useless. So let's change to mode 2. Mode 2 will tell you the existing indexes in this database. And like I said, this is one thing you have to consider before you create a new index. What are the indexes that currently exist? And how are they being used? Stuff like that. So these are across different tables because we are doing at database level now. So it's going to cut across all the tables in that database. And then mode 3 tells you the missing indexes, the indexes that are supposed to be there but are not there. And then the last mode, which is 4, pretty much like mode 0, gives you all the problems, the indexes, and then more. So these are the missing indexes now, mode 3. It's saying that you're supposed to create all these indexes in the post table. So when I was talking about equality and inequality the other time, see? So there's equality here, equality, but when it comes to this one, there's inequality, which means that the query that this index will benefit, these columns, one of them do not have, okay, it's just one column here as the key column, which is the title. The title is not, there's no equal sign there, it's inequality. And inequality does not mean greater than or less than alone. I think if you are using null is null, not equal to all those things, they still fall under inequality, as long as it's not equal sign. So there's so many things that go into indexes. That's why you don't just go ahead and run what SQL gives you, because it doesn't take into account the order. It just tells you these are the columns, but the order is not usually accurate. So you have to use your own skill as a DBA to reorder them so that they can be optimal for your queries. Okay, so you can run mode 4 on your own to find. So I've given the description of each mode here. Let's run mode 4 to practice and see what it's going to display for you. All right, so now the last step procedure we'll talk about is the one that helps us to find what queries are currently running on our server. Okay, which is a split who. Like who is running what at this particular point in time. So let's say as a DBA, you got pulled into a bridge curve, and it says server is slow. You want to find out, what queries are running, because the slowness at that time is caused by one or more of the processes that are currently running. So you want to identify which one of them. So this comes in handy where you want to do that, and very lightweight. It doesn't take much time. But there are two of them. So bleed who is part of the first responder kit. SP underscore who is active is not. So who is active was developed by Adam Mechanic to do the same thing as bleed who does. But who is active is lighter than bleed who. So if your server is really on fire, I would encourage that you run who is active, because bleed who might take longer because it fetches you more information. But who is active just gives you the basics you need to keep going. If you want to see what parameters they use, run these and you will see those parameters. I'm trying to save time here. So now, but the common parameters that I use with these, for example, the bleed tool is the expert mode, just to give me additional information in terms of memory grant, CPU time, and all of that. Right now, I don't have any query running on my server. So if I run this now, I should get an empty result set, except for system processes that are running. So how do you identify system processes? System processes are processes whose session ID is from 1 through 49, and they are unkillable. You cannot kill them because they are controlled by the system, by the database engine. For anything 50 and above, that's user processes, applications, users, then you can kill those ones. Let's say you're experiencing blocking and all of that. All right. I don't want to load this server because it's going to hang, but I prefer to use WizActive to bleed who. I just wanted to show you guys, but I think it's best to combine both of them. That way you can compare. I've noticed something. When you run both of them, the last time I ran both of them, WizActive reported more queries than bleed who, and the difference was because of queries using linked servers. So I don't know why. Bleed2 does not report queries that are using linked servers, but WizActive does. So in case you have you are heavy on linked server in your environment, you should use WizActive because you want to see what is causing the slowness for this linked server as well. Linked server queries as well. So if I run these, I'll get an empty result set too. For the most part, yeah, because there's nothing running. This is just for active queries. Once a query finishes, you won't see it here. And let me just stress load this for a few minutes and run so you can see the result sets. Okay, now it's running. So if I run this now, I'm gonna actually run both of them. Come on. So we're gonna see two result sets, one for bleed2, one for one for WizActive. And we can compare the results. Yeah, my server is on fire. So let me stop. I hope it captures something. Let me hold on a little bit more. Yeah, I'm just gonna kill it. Okay, all right. See, it's able to capture some stuff. You have the bleach who captured 3. One is on the system database. Why this one just captured just 2? They captured, yeah. And you can see that the result in different order in terms of the column. This one here is showing run date false followed by time. So the results are usually ordered in terms of duration, how long they've been running. So the top one is going to be the one that's been running the longest. That way you can quickly identify that, oh, this query is a long running query. What is causing it to run for this long? And you can kill it if you want to, stuff like that. And then session ID, this is the session ID of that, the speed of that query. If there's any query blocking that query, you see that under the blocking session ID. This is the database that the query is running in. This is the query that is actually running. This is the execution plan of the query. This is going to be like the estimated, and this is the live query while it's running, because this will only capture active query, remember? This is the cost of that query. This is the parameter that is used. This is like a stored procedure. So the parameter that is used, these are the values of the parameters used by those stored procedures. And then the cost of those queries is telling that they are currently running, the weights that the query is experiencing. See, CX packet for the first one. The second one is experiencing CX packet and page IO large. And then the top weights are these, and they put their time, how long each of these weight type has been waited for. And then if there's an open transaction, and blah, 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 where the query is coming from, and who is running the query. This is how you know who to reach out to when you want to kill a particular query. Okay, and then the application that the query is coming from. Because I'm loading from SQL Stress to SQL Stress here, and then this is for the other monitoring tool here. So they have pretty much the same thing, but just in different order. Just in different order. But there are some things you can tweak when it comes to who is active. So who is active normally would not give you execution plan, but Bleed2 gave us execution plan. So in order to have execution plan, you have to include this parameter, get plans, get underscore plans equals 1, then it will give you the execution parameter. If you have a lot of queries running and you don't want to see everything, you want to filter for a particular column. Let's say a particular login, you want to include this parameter, filter type, which means filter based on login for me. And then you supply what filter, what value of login you want to filter for. So when I run this, it's going to give me active queries that are executed by this login only, no other ones. And you can filter based on any of the columns. You can filter based on session ID. You can filter based on login name. You can filter based on CPU, TemD, any of these columns here you can use to filter, and then you supply the value you want. This parameter is useful when you're experiencing blocking and you are looking for the root blocker, the query that is causing the most, that is blocking the most queries, or that is causing the root cause, that where the blocking starts from. You want to put this there and it will help you to find it. And then it goes hand in hand with this other parameter to order or sort the results for you. That way, the query that is causing the most, or that is blocking the most queries, will be at the top. And that is the one you want to keep. Once you kill that one, the other ones will just go like that. But if you kill the victim, the perpetrator will still be there. So you want to kill the perpetrator, not the victim, the root blocker. And then if you don't like the order of these columns or how many columns are reported or displayed to you, you can change the order and how many columns you want, because there's a lot of them actually, and you probably don't even need all of them. So you can use this parameter called output column list and list what columns you are interested in to see. Maybe you just want to see the query text and the login name, and just put it there, and that's what it will display to you. Nothing more, nothing less. And then for bleach who, you can save the result to a table using this query. And even if this query does not already exist, it will be created for you. Weeks active can also be saved into a table, but the query is long, so I don't have it here. But if you go to the documentation, you will see that as well. Any questions? Oh, I have a lot of questions here already. Okay, I already answered this one. Is there a particular order on how index key column is arranged? Yeah, I think I answered that as well. You want to do the join first, followed by where, followed by order by, just the way SQL the order of execution. That's how you want to go. And then you also have to factor in whether it's equality or not equality sign there. And then the query you're optimizing, where clause, I don't understand this question. The query you are optimizing, where clause does it cover? If you can rephrase that question, because I don't understand. That's Evans. Evans I. Joey said, is there any possibility or instances where SQL Server Engine can consider index seek expensive and choose to scan instead? Yes. So index seek is not necessarily better than scan. And scan is not necessarily worse than seek. It just depends on the query. If you write a query without a where clause, you are leaving the engine with no choice than to scan because you are not filtering. So you want everything. So you have to scan everything to give to you. So you only seek when you have a where clause there and then you have an appropriate index. That's when it will dive right into where the data is and then seek it for you. Okay. All right. Thank you. Okay. So that's it when it comes to FRK. I've covered all the stored procedure that I use for the most part for troubleshooting in the first responder kit. So now, should we take a quick break or let's just wrap it up? So now let's talk about the monitoring tools. So in case your environment does not allow these, then they'll either have their own inbuilt stored procedure that they use or they have a third-party monitoring tool they use. So I'm going to show you how you can get similar metrics or you can troubleshoot just like we used FRK using the monitoring tool. So I have two monitoring tools that I wanted to show more, but I couldn't get some of them to work because of course it's just a demo. I didn't want to reach out to technical support or anything. So, but I do have SolarWinds DPA. I wanted to show Spotlight, but my license expired. I reached out to them for extension. They did not respond to me. That's bad customer service. If anyone here is working for Spotlight, tell them. And what else? And I also have IDERA diagnostic, whatever. That is also a good monitoring tool that I'm going to demo. Okay. Okay, so I'm going to start with IDERA. I'm not going to show you how I installed it. It's outside of the scope of this section. I'm just going to show you what you expect to see. So this is the UI of IDERA Diagnostic Manager. So if I click on this server, on that server, yeah, which is the name of my server, it's going to give me. So the benefit of all these monitoring tools is it's internally, it's doing exactly the same thing as those stored procedures that we explored earlier. The only difference is how the data has been presented to us. Those stored procedures will give us in the grid results, tabular form. This one, they give us in a pictorial form, like just they make it more visual, more friendly to use and interpret, to see and interpret. So here we have, and then the benefit of this is that they capture these metrics and store them over time. But those stored procedures, you have to be the one to store them. Like I showed you how you can save them to table from time to time. You can actually put them in an agent job and be saving them to table. But these ones, they will save it at least maybe like up to 30 days for you. You can go back in time to see what your server was doing some days ago at a particular time in case you want to troubleshoot. And that's what I'm going to show you here. So you can go start time. If I click on this calendar, I can go as far back as, I don't know how far back you can go, but my server has only been up for a few days. So let's just go back as, let's say 17. From 17 to this very moment. And it's going to show us all these metrics, how the the CPU is being used. You can see this is just me when I was stress loading the server. You can see that the CPU spiked here. When there's nothing going on, it is low. When you have queries running again, it goes up high. There's a bunch of other things here that we're not really interested in. Here, oh, this thing refreshes too quickly. I'm going to get out of this place and show you how you can identify resource consuming queries on this IDER. And all monitoring tools, they are very similar. So once you know one, you can carry that knowledge or experience over to any other one that you want to learn, and you'll be able to learn in a very short time. They just have different UIs, it's the same concept. The same DMV is running internally, and they're just displaying it in a graphical form. This one is taking forever to. Come on. Okay, you know what? Let's go to DPA. All right, so this is the interface of SolarWinds DPA. And if you come down here, oh, okay, let me go to home. Go to home. And you can monitor as many servers as your license permits you to. Obviously, I'm using a trial license, and it's going to expire in a few days because they gave me just 14 days to test this. So here, down here, this is where you will see the servers they're monitoring. In a production environment, you will see multiple servers here based on the license you have. Okay, and you can see that it's currently running, which means it is currently being monitored. It gives you an idea of the weight your server is experiencing. Yellow is like warning, red is critical, green is good. It tells you if you need to do any tuning here. So and then it shows you the health of your resources. See, CPU is green because there's nothing running currently. Memory is good, storage is good, session is good, alert is good, everything is good for now. Okay, so now if I go up here, okay, now I can just click on this. So now I want to dive into this server now. I'm going to click on the name of the server. Then it takes me to this page. I hope I'm not just loading these guys. Okay, takes me to this page. So yeah, and then it displays all these metrics for us in a graphical form. And then if I want to check how my servers are performing for like a while ago, since the time, usually shows you for a month. If you've been monitoring for a month, it shows you about a month worth of metrics. But I think I set it up on the 15th. That's why you can only see up to 15. But otherwise, you can go as far back as a month. Like it would have shown you till like January 20th if I had set it up there. And then so it shows you all days here by default. But if you want to narrow it down to a particular day, click on this and you can go to that particular day. So like I said, I installed it on the 15th, so you cannot see anything prior to 15. Let's say I want to narrow down to, let's just say today, everything we've done today. So Saturday 21st, click on this, and it will show me all the queries that have been executed on that server today from 12 a.m. to this very time. Okay, and this tab here is SQL. These are queries that have been running on this server. And then there's a legend here that's, let's say I'm interested, like, okay, at 12, is this particular, if you look at the bar, that's how long this query took to complete. And this one has the longest bar. Let me highlight that. This one right here. Yeah, took the longest to complete. So if I'm interested, well, why did this query take this long to complete? And the same query, we have the same color code. Okay, the same query, we have the same color code, every time it appears or it runs. So if you look at this query and this, sorry, I'm colorblind, so forgive me. I believe that this color and this color are the same, if I'm not mistaken, right? Yeah. So if you have been monitoring this query for a while and you notice that this today, the duration was small, then small, and all of a sudden, bam, it's this high. The bar is this high, which means it took longer than expected. You might want to drill into that query to find out why it took that long. So you can just hover your mouse on it to see the query, and then you can click on it to drill, into that particular query. And then, yeah. So now this is that particular query now. And then we can see the different weights that that query has experienced within this time frame. Just within this time frame. Today, between 12 and 1. These are the different weights this query has experienced. So, okay, these are different queries, but these are the different weights those queries have experienced, and they are color coded. So green has to do with memory and CPU, and this one has to do with memory as well. CX packet is, I think this is pink or something. And you can just begin to, go. So that query, I just clicked on it. It should show me the text of the query. So that's the top query for this time period. You can see it executed from 12:30 to 1. And these are the weight types that they experienced. If I come down, scroll down here, I can check the text of that query by clicking on SQL text. So this is the text of that query. There are some bottlenecks that you can detect right off the bat by looking at the query. Some you cannot. You have to explore the execution plan to find what is wrong with that query. But for a fact, I know that this is parameterized because of this. And if it's a stored procedure, you might be experiencing parameter. Yeah, it is a stored procedure. So you might be experiencing parameter sniffing. You can just have an idea of what you expect in that query. So this where clause here, you see, this is inequality because this column is not. It's not equal to it. So when you have is not, that's some inequality in terms of the uh, index. This is also inequality right here. But this is equality. This is also equality. So when you are creating an index for this query, you have to take account of how you want to order these columns. These columns now, this one, and this one, and this one. You have to take account of how you want to order them so that they can be optimal for this query. And sometimes it even gives us recommendations of what index to create, just like SQL Server does. And all those things are actually captured from the engine and it just displays them here. How you can tune, it gives you advice on how to tune the table, how to tune the index, blah, 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 blah. In the production environment, you see those, but because my own server is bored, I don't see anything here. So let me go back. So if I come to databases, you can see what database is experiencing the most weight within this time period. Obviously, the DBA database, because that's where we've been running those stock procedures, the first responder stock procedures from. And if you want to see the weights, the different weights queries I've experienced within this time frame, that's 12 to 1 today, these are the different weight types. And memory/CPU being the highest one or the longest one. If you want to understand each of these stock procedure, just click on them. I believe there's an explanation for each of them. Yeah. So you click on them, it will tell you what they mean. I used to use this a lot to learn while I was still, learning performance tuning. Tells you blah, 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 what you need to do, recommended solutions and all of those. So it's pretty cool. Okay. Then you can, let me go back to this. And out of all the days, like since you've been monitoring, you can also see all the weights, the cumulative weight server has been experiencing for different days. Then you can compare the trend. So on the 15, if you look at, so I waited on memory for about 20 minutes. On the 16, it's longer. The green bar here is longer. And on the 17, so you can track the trend over time and see if you're doing better or worse. If your server is doing better or worse, you can see all of that. On a typical day, you can also see that as well, like an average, see what your server is experiencing in terms of different weights. You want to, so as you're doing performance tuning, you're expecting that all these bars, their height will reduce, which means your server is getting better, the weight is getting shorter. That's the expectation. So that's why I love this monitoring tool, because you can track your progress as you're tuning your server. So here you see the different programs running or throwing queries at your server. Yeah. So most of the queries are coming from SQL Stress, obviously, followed by these, and at different days you can see all of that. You can see what database is going through the most fire as well at different days, where the host, where the queries are coming from, like the application server. This is my server name, awaits, and then this is my VM name, prod01. You can see the different users running those queries. You can see the storage files, the data file, the log file for different databases. You can see which one is like experiencing slowness. So this is good when you want to analyze the storage speed. And the top drives, because my D is my data drive, so that's where we hit the most when we run queries to fetch data. So I believe these are execution plans. Yeah, only active for cast plans. So these are execution plans. So if you want to look for a particular SQL, you can use this. Find SQL. You know how we run SP bleed cache to find those SQLs that are run in the last, certain minute or so. This is the equivalent of that. So here, as you can see, in the last 24 hours, it's giving us all the queries that have been executed here. But this is better because it goes longer, or it goes longer in terms of time travel compared to the bleed cache. Bleed cache can only go as far back as 90 minutes. This goes hours, days to find those queries. And if you scroll down, you see all those queries that I've executed on the server in the past 24 hours. And you can drill down into them and start looking for stuff. You can export them to CSV if you want. And then here, where it says tuning, it gives you tuning recommendations, what you can do to improve the performance of your server. It gives you index recommendations, query recommendations. So here, it's telling us that this query has plans indicating a full table or index scan, and 77% of the wait time was spent on CX packet. So it's pretty much telling us the weight associated with each of those queries, just like we were doing with SP_blitz first. And then on the right here, it's telling us that there's a problem with this vote table and that one query may benefit from tuning this table, like creating indexes or whatever. So let's click on this, see what it's going to tell us. So it says there is inefficient table or index access discovered by DPA. This is not useful at this time because it's not giving us any index recommendation. View plan details. So for that particular query that it thought would benefit from tuning that table, this is the execution plan. And majority of the cost is coming from the sort operation. So if we create an index on whatever we are sorting on, that would help this query. And if you hover your mouse on an execution plan, you get more information about that operator. So if you go down these prompts or pop-up, you see order by. That's the sorting. So what column are we sorting on? Creation date. Do we have any index on creation date when we go to check the vote table? No. Which means if we create an index on creation date, this query will run faster. So that's how you have an idea of what to do to fix the problem. You can also generate reports by clicking on reports here. So you can generate report to send you, so these ones are generated by default. It's going to send you the top queries, the environment daily, depending on what schedule you put actually. But you can do daily. If I click on this, see top 15 queries. So these are like SP cache, and it's going to send it to you. That runs every day. It sends it to your email. So if I do this, I click on display report. That is what I will see in my email every day, depending on what is going on. I can get this in my email every day. That way I have an idea of how the queries are performing, even without coming to logging into SolarWinds. So you can, these ones are already created. You can create additional reports. So here it says create a new report. The database instance is probably one because this is the only server I'm currently monitoring. So what type of report do I want? Come here to select what report you want. Do I want the top SQL report, the top weight, whichever one you want, click it and then click report options. Or if you want to preview it, like what it would look like when it sends this to you, you can preview or click preview reports. How many weights do you want to see? You can select whatever number. It's top 5, top 15. It's up to you. The date, the hour range from 12 to 12 plus the entire day. Then you can give it a name, give it a title, give it a description. I already have my email set up somewhere, so he sends it to me. If you want to set up alerts, same thing here. Click on alerts here. I don't have any alert, but you can just create an alert. What are you creating an alert on? Let's say resources. You want to track CPU usage. Single resource, blah, 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 blah. And then I'll say create an alert. Categories, CPU. So what threshold do you want? So which means it's going to alert me when the CPU usage is above 75. So here is CPU utilization. Okay. So once I'm using up to 75% of my CPU, I'll get an alert. And then how critical do you want it to be? You set all those ones here. Who do you want to send it to? You know, you want to send a critical alert to your DBAs, then the warning maybe to your manager or whoever is on call. And then you create an email template here. So all kinds of stuff. If you want to add additional servers to monitor, you come to options, and then you can register other instances in your environment here. Click on register, then you select your database engine, which is Microsoft. If you have Amazon RDS or Azure, just select whichever one you have accordingly. Next, you put your server name or the IP address. You put the port your server is listening on. What authentication do you want? You keep nexting, and then bam. I don't have any other server to monitor, so I'm not going to finish that. And then the good thing about this is if you have any issues, you can always reach out to the technical support. So they usually assign a tech support for every company to help them with the setup, with the configuration and all those things. And then they will give you training, demo on how you can use it and then, stuff like that. Then you can also virtualize. So everything that we've been checking so far is at the SQL Server level. If you want to check stuff at the OS level, you can virtualize it by coming to this virtualization here. But I don't have the VMware or the vCenter, so I'm not able to virtualize. But if I was able to, I would see CPU, memory at the OS level, the entire server level, and I would know how my server is performing. I can track the trend and all of that as well. But right now, I'm only checking performance. But in a work environment, we usually have this setup. So let's go back to this guy, see if it's up or it's still doing. Oh, all right. Any questions? Sorry, took a lot of your time, but I believe we learned new stuff. Okay, so if I come to queries before it disappears again, queries here, I can also change my time, just like we did in SolarWinds. Can go back in time. So these are the queries running. You can filter your query based on different resources, CPU, memory, all of those things to identify those queries causing those bottlenecks. So in a nutshell, this is how I troubleshoot and monitor performance of SQL Server databases. Any questions?
I dropped a question on the chat.
When deploying SolarWinds monitoring, is it considered the best practice to provision a separate server or VM to host repositories or supporting components? Of course, if you can dedicate a server for it, yeah, why not? That way you're avoiding contention. But as long as you have the budget for the license, because the database will have to be on the SQL Server engine, right? So,
Right.
and you have to pay for additional license because it's a separate server. But at least you're avoiding contention. So yeah, it's a good practice.
Okay. because I did it one time and I was just wondering. But ever since then, I've not touched that server for over 2 years now. So, okay. I
All
didn't know
right,
about it.
I'm gonna stop recording.